Hello students, I welcome you all in this video. In this video, we are going to talk about a question which is based on pseudo force, right? So let us see what's the question. The question we have is, figure shows a box of mass small m is placed on the wedge of mass big M on a smooth surface. How much force F is required to be applied on the big M so that during motion the small m remains at rest with respect to big M, right? So see, the very first part of the question is this surface is frictionless. Here we don't have any kind of friction. And then how much force we have to apply on this big M such that the small m will be at rest with respect to the big M, means with respect to wedge, right? So here what is happening, if you talk about the wedge, that is basically an accelerated frame of reference, right? So what exactly happening here? We are applying a force on the big M, but the small m is at rest. And why it is at rest, we have to check that first. Okay, so let us talk about a person who is sitting on this wedge, because we are going to draw the free body diagram of the small m with respect to a person who is sitting on the wedge only, right? So let us see that. So this is the block we have, right? And the very first force of the block with respect to the person sitting on the wedge is just mg. That's the first force. And there's a normal reaction like this, right? Now, if you talk about the angle, this angle is theta. And see, here if you can observe, this is the normal reaction and this is the vertical line. We need to find out that angle. See, there's a concept in physics. If you have two lines which are making an angle theta with each other, then angle between their perpendiculars will also be theta, right? So normal line is perpendicular to the inclined line, and this vertical line is perpendicular to the horizontal line. So this angle has to be theta only, right? So now if this angle is theta, then what can we say? This angle is theta, then we can do the component of n, and that is going to be n cosine of theta, and this is going to be n sine of theta, right? Here the x and y axis that I have taken x and y axis like this. I have taken this as the y axis and this as the x axis, right? Now let us talk about this person who is writing this equation. Since that person is in an accelerated frame of reference, so laws of motion is not valid with respect to that person. So what we are going to do, just to make the laws of motion valid with respect to that person, we have to apply a force called pseudo force, and that is the mass of the object on which we are applying times acceleration of frame of reference, right? So that is going to be m times a this way. Okay, now this wedge small m is at rest with respect to a person who is sitting on the wedge with respect to the accelerated frame of reference. Okay, so now what can we say? If you talk about the vertical equilibrium, you will say this n cosine theta is basically mg. And if you talk about the horizontal equilibrium, you will say that this n sine of theta is basically ma. Let's consider this equation 1, this as equation 2. So what we can do now, we can divide these two equations, n and n get cancelled out, m and m get cancelled out. So here tan theta is going to be a over g. That means acceleration we got is g tan theta. So basically what is this acceleration means? This is the acceleration with which this entire system has to move rightward such that the small m will be at rest with respect to big M, right? So this has to be acceleration. Now we have the acceleration and we need to find out the force. I think this is the easiest job to do, right? Because since we have total mass is small m plus big M and this much is the acceleration, so we can easily get the force. The force has to be total mass, which is m plus m, that times acceleration of the system, that is g tan of theta. So this much is the force we have to apply to keep small m at rest with respect to big M, right? So this was the concept of pseudo force. I hope this is clear to you guys. Thank you.